This is the continuation of part 3, talking about electromagnetic waves. And where we left off last time was we were talking about the electromagnetic spectrum. So if you take a look at this diagram here, we see that the electromagnetic spectrum is the complete range of electromagnetic waves, and that's in order of increasing frequency. So we see over to the left, we see radio waves that have long wavelengths and a low frequency, all the way to the right where we have our gamma rays that have short wavelengths and high frequencies. So let's talk about each of those different types of waves that you might see on this electromagnetic spectrum. The first wave that we're going to discuss are our radio waves, and that's all the way to the left of the electromagnetic spectrum. Okay, because these electromagnetic waves, they have the longest wavelengths and the lowest frequencies. Okay, you can find radio waves as either broadcast waves or microwaves. Both of these are classified as radio waves. So when we talk about the broadcast waves, these radio waves with the longest wavelengths are used in broadcasting. These radio waves carry signals for both radio and for TV. What happens is that your radio or TV antenna will pick up the wave. Okay, so it picks up the waves and converts that radio signal into an electrical signal. So all of the things that you listen to or that you watch are all related to these broadcast waves through radio waves. So maybe you've wondered about AM and FM radio stations. Well, what's the difference? So let's take a look at this website. Okay, this is through a Science Odyssey, okay, through PBS. And it tells you what's the difference between AM versus FM. So AM actually means amplitude modulation, and FM means frequency modulation. So FM radio works the same way that AM radio works, but the difference is how that wave is modulated or how it's changed. So with AM radio, the amplitude or the energy or the strength of the signal is varied to incorporate your sound information. But with FM, the frequency, which how many crests and troughs there are, so the frequency of that carrier signal is then varied. But FM signals have a great advantage over those AM signals. Both signals are susceptible to slight changes in amplitude. And with the AM broadcast, these changes result in static. But with an FM broadcast, any changes in amplitude don't matter because the audio signal is conveyed through changes in the frequency and not in your amplitude. So the FM receiver can just ignore the changes in amplitude, and so there's no static at all. So if you're listening between an AM station or an FM station, and there are some like 97.1 The Fan, where you can listen both on an AM station and an FM station, and if you listen to one on the AM and then switched it to the FM station, you're going to be able to tell a huge difference in the quality of that sound because that FM is changing just based on its frequency rather than relating to its amplitude. And so there's no static and that sound quality is a little bit clearer than if you were listening to it on that AM station. Okay, so let's go back to our notes. Our next part is talking about microwaves. Okay, the microwaves, these are the radio waves with the shortest wavelength. Okay, so we know that radio waves in general have longer wavelengths and lower frequencies, but if you're trying to look at your radio waves, the longer part of the radio waves to the far left side of the spectrum are making up your broadcast waves. And if you're looking at radio waves again, that part that designates radio waves, to the right of that are your microwaves because they're going to be a little bit shorter in wavelengths with higher frequencies. So microwaves, these are radio waves with the shortest wavelengths and the highest frequencies. So this actually includes cell phone communication and radar in addition to microwave ovens. Okay, so your cell phone actually communicates through microwaves. So a radar it is used, it's a system that uses reflected radio waves to detect objects and measure their distance and speed. So what does radar actually stand for? So it stands for the RA in radar stands for radio. The D stands for detection. The A stands for and the last R stands for ranging. Okay. And of course we know that microwaves are used in your microwave oven at home. Okay, so here's a picture of how a microwave oven works. Okay, it produces those microwaves and is able to scatter those throughout the oven to reach the food that's being cooked. Okay, so we have some microwave popcorn in this figure of a microwave. We know that you put that in the microwave oven. Okay, you shut the door and the door is sealed so the microwaves cannot escape. It also has like a little metal grid on that window of your microwave so that those rays are then reflected off of that. In the top of your microwave, there's a rotating paddle that's able to scatter those microwaves throughout the oven once they're produced. How are they produced? Well, you have a magnetron that produces microwaves. And then the microwaves travel through a tube and into the oven. Okay, and then there's that paddle again that's trying to scatter those microwaves to try to cook your food evenly. You might also notice that some of those microwaves will have a turntable to try to help in cooking the food a little bit more evenly than a microwave that doesn't have a turntable at all. Okay, the next waves that we're going to talk about are infrared rays. Okay, and these are electromagnetic waves with wavelengths shorter than those of the radio waves. So you might see infrared rays with heat lamps because infrared rays generate heat, and also infrared cameras that are able to detect body heat. Okay, the next part will be visible light. These are electromagnetic waves that you can see. Okay, so these electromagnetic waves, they have wavelengths that are shorter and with higher frequencies than that of infrared rays. Okay, and the visible light spectrum is organized by wavelength from longest to shortest, and one way that you can remember is Roy G. Biv. So we have red, okay, orange, say yellow. I don't know if that will show up here. Barely. Green, blue, and violet. Okay, so if you take a look at this spectrum of visible light, we know that the longest visible wavelength is red. So it's easy for you to remember, okay, infrared is right before you get to visible light, okay? So because here's your infrared part, okay? So this even says red. And then the shortest wavelength in a visible light spectrum is violet. So then whenever we go to the next part talking about ultraviolet rays, we know that that's right after your visible light spectrum, and that's even shorter wavelengths than your visible light spectrum. Okay, because ultraviolet rays, those are electromagnetic rays with wavelengths just shorter than visible light. Okay, so they have higher frequencies than visible light, so they can carry more energy. The energy of ultraviolet rays is great enough to damage or kill living cells. Okay, so that's why it's always important for you to wear a sunblock that will try to block those ultraviolet rays from the sun. Okay, the next ray that we'll talk about are X-rays. Okay, and these are electromagnetic waves with wavelengths just shorter than those of ultraviolet rays. Now their frequencies are a little higher than ultraviolet rays. Because of their high frequencies, X-rays carry more energy than ultraviolet rays and can penetrate most matter. So it could go through most matter. So dense matter such as bone or lead absorbs X-rays and does not allow them to pass through. Okay, the film is darkened where the X-rays pass through and then appears lighter where the X-ray is absorbed. Okay, so we know that X-rays are used so that way you can see if there's anything broken in a bone or if you have any cavities if you go to the dentist. But you also might notice that when you go and get X-rays taken that they put that lead apron on you over the rest of your body so that way the rest of those X-rays that you don't need going through a particular area are then absorbed by that lead apron. Okay, the last and the very shortest electromagnetic wave is the gamma ray. Okay, these electromagnetic waves have the shortest wavelengths and the highest frequencies. And because gamma rays have the greatest amount of energy, they are the most penetrating of all the electromagnetic waves. So what do you do with the gamma ray? You can actually use this as a way for cancer treatment. They have gamma ray surgery that they can focus the gamma rays on certain parts, maybe cut out a tumor or something that shouldn't be in the body. And it's also related to explosions of stars in distant galaxies. So all of those things are related to gamma rays. Okay, so thank you for listening. If you need to repeat any of those parts, feel free to rewind this recording.